Black holes are one of the most fascinating cosmic phenomena of all time, producing a gravitational field so intense that even light cannot escape it. These extraordinary objects captivate astronomers to no end, and the possibilities that arise from them are absolutely stunning. We've discovered some spectacular feats, from black holes dozens of times larger than our entire solar system to the active quasars shining brighter than trillions of stars. This is only just the beginning, and today we're venturing to the craziest black holes we've ever discovered. Black holes are pretty common when it comes to the universe, but even the closest black holes to Earth lie thousands of light years away. Gaia H1b, for example, is the closest known black hole to Earth, 3 times closer than the second closest black hole. What's interesting about this one is how it was discovered. While black holes are characterized by the void formed due to their intense gravity, the matter surrounding the black hole does the exact opposite. This secreting matter can become so hot and so luminous that it can be detected by telescopes billions of light years away. This is how we discover the vast majority of black holes. However, this is not the case for Gaia H1b. In this system, we see a star orbiting around a central point. This point is the very center between the star and another object. Through further investigation, it was obvious that this was a mysterious case of astrometric perturbation. The object was estimated to have a mass of nearly 10 times that of our Sun. This insane mass is impossible for a star or an exoplanet to contain without emitting some form of light. Not only was the object seemingly invisible, but it was also extremely massive. This led astronomers to the inescapable conclusion that the system must contain a black hole. While this star is pretty safe from its parent black hole, the star in our next system has a different story. Approximately 215 million light-years away, a tidal disruption event occurred in a distant galaxy. A tidal disruption event emerges when a star is perturbed and ripped apart by a supermassive black hole. Shortly after this massive flare, astronomers locked their telescopes onto the event, cataloged AT2019 QIZ. They were able to gather details about what had occurred by observing the aftermath of the event through polarized light. This allowed them to investigate what actually happened, and their data showed that despite the eruption that emerged, most of the star's material didn't directly enter the black hole. Some of the star's material was flung into space, similar to this simulation created by NASA. The star's trajectory reached a maximum speed of 6,200 miles per second. The remaining material stayed relatively close to the black hole, orbiting it periodically and forming what's known as its accretion disk. So far, we've talked about the interaction between black holes and stars. But what lies in PKS 2131021 is a feat rarely seen before. This is a binary black hole system present in a distant galaxy. This system contains 2 black holes, one being a quasar and the other one being quiescent. A quasar is a very fiery and active black hole, hundreds of millions of times more massive than our entire solar system combined. This is one of the few systems with multiple black holes, and within 10,000 years, we might see a feat we've never seen before: a black hole collision. This event would send ripples into space, two strong gravitational influences impacting and sending signals across the universe. These signals are known as gravitational waves, and the effects of this event will spread across the cosmos, and soon these waves will one day reach Earth for us to observe in great detail. This, however, isn't the only binary black hole system we've found, and our next one takes an unexpected turn. OJ287 is another binary black hole system containing a quasar, OJ287A, with a secondary black hole orbiting it, OJ287B. The primary black hole has a thick accretion disk that is perpendicular to its companion's orbital path, and as a result, the secondary black hole crashes into the disk with such a ferocity that the event is brighter than 1 trillion suns. These extremely luminous flares occur irregularly due to the secondary black hole's complex orbit. OJ287b orbits its more massive companion every 12 years. But because of its immense orbital precession, this orbit shifts and creates irregular bursts in the disk. Many mysteries lie in OJ287, and while it releases extreme amounts of light, it cannot compare to 3C273, the brightest quasar we've ever discovered. Located 2.5 billion light years away, 3C273 burns at over 10 trillion degrees, with an absolute magnitude of -26.7. This absolutely astonishing brightness makes this quasar 4.1 trillion times the brightness of our sun, a feat rarely seen before. While this black hole is greatest in optical brightness, our final black hole dominates every black hole ever seen before. "8.5 billion light years away, a monster lies within the Phoenix cluster, the central black hole, Phoenix A star. Phoenix A star is the largest black hole ever discovered, with an estimated mass of 100 billion times that of our sun. This is equivalent to 440 duodecillion pounds. The immensity of this giant is simply incomprehensible. If you were to take every single star in our galaxy, each one being hundreds of millions of times more massive than Earth, and combine all the masses, it would only be half the mass of the largest black hole we've ever discovered. Millions of black hole systems exist in our galaxy alone. What we've discovered is just the beginning. I'm Joshua Carter, and this is Astroconcepts.